For as long as we can remember, scientists have been making unique discoveries in space, and some of these findings are often unclear to them. Because of this, scientists decided there was a need to create powerful tools to help them analyze their discoveries better. As a result, high-end technological tools were invented to assess the solar system and its components, and one such tool is the powerful James Webb Telescope. On one of its recent assignments, the James Webb Telescope made a shocking discovery on Jupiter that has left scientists with more questions than ever before. What was this discovery, and how will it change our knowledge about the final frontier? Join us as we explore James Webb Telescope's shocking discovery on Jupiter and how it changes everything. The James Webb Telescope is one of the greatest and most powerful telescopes currently used by astronomers. Launched on December 25, 2021, it is a space-based observatory with a huge and impressive telescope that orbits around the Sun. The JWST is a successor to the Hubble Space Telescope designed to display and discover objects in space with a much clearer view than the Hubble Space Telescope. Although the Hubble Space Telescope achieved impressive milestones as it gave much clearer views of space than scientists had seen, the JWST is far better. It is programmed to be about 100 times more sensitive than Hubble to let astronomers observe more distant and far dimmer objects in space. It also lets astronomers observe objects within close range in greater detail. The telescope's innovations came as an effort from the National Aeronautics and Space Administration in the United States, the European Space Agency, and the Canadian Space Agency. This incredible innovation was then sent to observe Jupiter, which made a discovery that scientists never expected. The James Webb Telescope was sent to observe Jupiter for the first time to show a view of the planet. Jupiter, the biggest planet in our solar system, holds several phenomena yet to be uncovered by scientists and astronomers. However, scientists know that the planet has several wonders, such as powerful winds, giant storms, pressure conditions, and extreme temperatures, only to mention a few. This is why astronomers directed the JWST's view to Jupiter. The telescope took new images of the planet and sent them back to Earth, and when scientists got the images, they were mesmerized. The photos were breathtaking as they saw the biggest planet in a different light compared to what they had previously assumed. Imke DePatter, a planetary astronomer and professor emerita at the University of California, Berkeley, recalled how shocked she was when she saw the images for the first time. She said the whole team was left jaw-dropped because they didn't expect the details of the images taken to be that perfect. It was an incredible sight as the team of scientists saw Jupiter in a detailed view. Its rings, galaxies, and tiny satellites were all captured in one image by the James Webb Telescope, leaving them marveling at the discovery. Their mission to Jupiter was part of an international collaboration for Webb's early release science program, so she led the Jupiter Observations program with Thierry Fouché, a professor at the Paris Observatory. Both images taken came from the observatory's near-infrared camera, NIRCam. The near-infrared camera is equipped with 3 specialized infrared filters that portray the planet in full detail. Since infrared light is not visible to the human eye, the light was mapped onto the visible spectrum. As a result, the shortest wavelengths were shown as blue, while the longest wavelengths appeared redder. Having seen this, the scientists called a citizen scientist named Judy Schmidt to help translate the data from the James Webb Telescope into images. When a standalone view of Jupiter was created from a blend of multiple images from the JWST, auroras are seen extending to high altitudes over the northern and southern poles of Jupiter. The auroras glow in a filter mapped in redder color, highlighting the beams of light reflecting from upper hazes and lower clouds. Another filter was also used, mapped to yellow and green, as they detect hazes moving around the southern and northern poles of the plane. A third filter, mapped to blues, also showed light reflected from a deeper main cloud. Sights like the Great Red Spot were detected as white spots in these views, including other clouds, because they reflect a huge amount of sunlight. The brightness coming from these sights indicates high altitude, meaning the Great Red Spot has high-altitude hazes in the equatorial region. Observing Jupiter from a wide-field view, the JWST detected its faint rings. These faint rings are 1,000,000 times fainter than the planet. The telescope also captured 2 tiny moons, Amalthea and Adrastea. In the lower background of the photo, there are fuzzy spots that are likely to be galaxies, photobombing the Jovian view. A scientist on the Jupiter observation team, Thierry Fouché, made a statement on the wide-field image saying it depicts the science of the Jupiter System program. The Jupiter System program studies the dynamics and chemistry of Jupiter, its rings, and its satellite system. With this program, researchers have been able to analyze Webb data in order to obtain new scientific results about our solar system's biggest planet. However, data from the James Webb Telescope does not arrive here on Earth as completely packaged. Instead, it supplies only information about the brightness of the light on the JWST's detectors. This information is then sent as raw data to the Space Telescope Science Institute, JWST's Mission and Science Operations Center. From there, the Space Telescope Science Institute transforms the data into calibrated files for scientific analysis and transfers it to the Mikulski Archive for Space Telescopes for dissemination. After scientists get this information, they convert it into images during their research. While scientists are converting this information into images, non-professional astronomers known as citizen scientists are invited to review the public data archive to retrieve and process images. After the James Webb Telescope made this discovery, a team of scientists kept researching. Their study found that Jupiter's gaseous envelope doesn't have a homogeneous distribution, and its metallicity gives clues about the planet's origin. It all began with NASA's Juno space mission in conjunction with the James Webb Telescope. When scientists began observing Jupiter, they noticed that the planet was filled with hurricanes on all parts. This sighting almost gave the planet an appearance similar to a Van Gogh painting. The planet's envelope underneath the thin visible layer, however, was not visible. That wasn't an issue for the equipment used in observing the planet, as they could sense the gravitational pull above different locations on Jupiter. It also provided information about the interior's composition, which did not correspond with what scientists usually see on the planet's surface. The international team of astronomers led by Yamila Miguel, an assistant professor at the Leiden Observatory, discovered that the gaseous envelope is not as homogeneous and well mixed as scientists once thought. Instead, they discovered that it had a higher concentration of metal-like elements. These metals were detected as heavier than hydrogen and helium and were spotted near the planet's center. To get their answers, the team devised several theoretical models that comply with the observational constraints of Juno and the James Webb Telescope. The team of astronomers proceeded to study the distribution of metals found towards Jupiter's center because it gave information about how the planet was formed. The scientists later found out that the metals weren't exactly distributed homogeneously across the envelope because more metals were located in the inner parts than in the outer parts of the planet. The total was added to between 11 and 30 Earth masses worth of metals. Judging from these discoveries, the lead researchers stated, "There are two mechanisms for a gas giant like Jupiter to acquire metals during its formation, through the accretion of small pebbles or larger planetesimals. We know that once a baby planet is big enough, it starts pushing out pebbles. The richness of metals inside Jupiter that we see now is impossible to achieve before that, so we can exclude the scenario with only pebbles as solids during Jupiter's formation. Planetesimals are too big to be blocked, so they must have played a role." So finding that the inner part of the planet's envelope consists of more heavy elements than the outer part only implies that metal's abundance decreases with a gradient instead of a homogeneous mixing across the planet's envelope. Scientists have previously thought that Jupiter had convection characteristics similar to boiling water, making it completely mixed, but the discovery made by this team of astronomers gives a different outcome. Regarding discoveries on Jupiter, scientists do not cease to amaze us, as some researchers at the University of Gothenburg found evidence that double ionized sulfur dioxide contributes to forming oxygen molecules. This discovery also serves as a factor explaining the presence of oxygen in sulfur dioxide-rich atmospheres detected in several of Jupiter's moons. Does the detecting of oxygen mean life can be possible on Jupiter? As explained by scientists, oxygen formation starts with a biological process of photosynthesis developed by cyanobacteria and started the Great Oxidation Event about 2 billion years ago. Researchers are also aware of some non-living parts in an ecosystem that helps in the formation of oxygen, particularly in space. On other celestial bodies where such bacteria are not present, the presence of oxygen can be explained by abiotic processes. This is why researchers dug deep and discovered a new abiotic pathway, oxygen formation from sulfur dioxide. The sulfur dioxide molecule is evident in the atmosphere of several celestial bodies, and huge quantities can be passed into the atmosphere during volcanic eruptions. When the sulfur dioxide molecule is left bare to radiation of very high energy, for example, the sun's radiation, it would make the molecule become ionized into a double positively charged system. From there, it can undertake a linear form with both oxygen atoms being adjacent and the sulfur atom at one of the terminal ends. Before it becomes ionized, sulfur dioxide has a shape synonymous with the Mickey Mouse shape of the water molecule. However, it's different when the atoms switch places in the molecule. Upon double ionization, two bound electrons in the molecule get ejected, which can lead to changes in the angle between the atoms in the molecule. It could also take a different turn, as said by Mans Wallner, a doctoral student in physics. Double ionization could bring about roaming. The atoms would switch places, making the molecule take on a new shape. Once roaming comes into play, the sulfur atoms may break up, leaving just a simply charged oxygen molecule, O2+. This oxygen molecule can then be neutralized by getting an electron from another molecule. This order of events can explain the presence of oxygen in Jupiter's moons such as Europa, Io, and Ganymede, despite the lack of biological life there. One of the scientists who made this discovery, Raymond Feifel, also suggested that this occurrence happens naturally on Earth. So if it happens on Earth, is that a chance for humanity to thrive in these environments? Recently, a fascinating comparison of the earliest photograph ever taken of Jupiter and the most recent James Webb Space Telescope image has been shared by astronomer Jasmine Singh. The earliest photo was taken in 1879 by Agnes Mary Clerk, an Irish astronomer who then published it in her book titled A Popular History of Astronomy During the 19th Century. This side-by-side comparison showcases just how far astrophotography has improved in the last 1.5 centuries. The photo from the 19th century is black and white and grainy. However, it is still obvious that the planet in the image is Jupiter because of the distinctive banding caused by differences in chemical composition and temperature of the atmospheric gas. The great red spot is also quite visible in Clerk's photo, but because the image is upside down, it appears as if it's in the northern hemisphere instead of the southern. The spot is also markedly bigger in the older image. The greater size has been backed up by various studies. At one time, this storm was so big that 3 Earths could have fit inside it, but now it is estimated that only 1 Earth could fit inside it. Against the James Webb photo, Clerk's image seems like a toddler's drawing, but the field of astronomy has come a long way in the past century, and the JWST is quite an astonishing invention that Clerk didn't possess at the time. However, these aren't the only images of Jupiter. The infrared view imaged by Gemini North Telescope in Hawaii on January 11, 2017 is also quite astonishing. To a common person, it looks like a ball with bands of fire. The Hubble telescope has also photographed Jupiter and its icy moon Europa in 2017 and 2020 respectively. Jupiter is festooned in rings, although it came as a complete surprise when they were discovered by NASA's Voyager 1 in 1979. The rings contain particles that are small, dark, and difficult to see. However, you can't talk about Jupiter without mentioning its moons, and it's one of them that is giving NASA scientists sleepless nights. Jupiter is known as a miniature solar system because of its numerous moons. The exact number of moons attached to this planet is a moving target as scientists keep discovering more. To date, not less than 79 moons have been found orbiting Jupiter. Its large mass, more than 300 times the Earth, gives it the stability to exert gravitational force over a large area and keep multiple moons in place. The 4 largest Jupiter moons are known as Galilean moons because they were discovered by Galileo Galilei. They are named Europa, Ganymede, Callisto, and Io. In the order of arrangement, Callisto is the furthest from Jupiter. It is also the smallest of the 4 and the most heavily cratered object in the solar system. It's about the size of Mercury but endures the least magnetic force from Jupiter. Ganymede is next to Callisto and is the largest of the quartet. It has the distinction of being the only known moon in the universe to have its own magnetic field. Europa comes next with a size similar to the Earth's moon. This satellite is full of cracks and streaks on its icy surface and has a high degree of reflectivity, making it one of the brightest moons in the universe. Europa is intensely studied by scientists because it's suspected to harbor an ocean beneath the ice that might contain life. On the other hand, Europa, the sixth largest moon in the solar system and the fourth largest moon orbiting Jupiter, may have liquid water encased within its icy shell. It is an ocean world with a heavy layer of ice covering it and snow drifting upward. NASA's Galileo spacecraft passed by Jupiter's frozen moon Europa in 2000, but the Juno probe recently made the closest approach in 22 years, offering the greatest glimpse of the ocean world since then. One of only 3 close-up views of the ice world ever, the 2-hour flyover passed just 219 miles, 352 kilometers above Europa's surface. The most recent observation of this kind came from Galileo on January 3, 2000. Tall shadow-casting blocks and other hard-terrain features can be plainly observed, and the surface is curved by bright and dark ridges and troughs. It's possible that the oblong crater next to the Terminator is an old impact crater. Officials describe Juno's unique perspective as essential to establishing observations for NASA's upcoming Europa Clipper mission, which will launch in just 2 years to explore the ice moon, even though geology data from the flyby is only now beginning to arrive. The Galileo orbiter, the Voyager 1 and 2 spacecraft, and earlier imaging missions of Europa have discovered that material that appears to have welled up from underneath has colored some of the moon's surface. The makeup of this substance will be examined by Juno's infrared camera and spectrometer to ascertain whether it is formed of salts or organic molecules. According to one theory, pockets of water can emerge below the surface either as a consequence of ice melting or as a result of liquid convectively rising through the ice shell, possibly as a result of forces put on the ice by Jupiter's gravitational tides. If there are any pockets of water near the surface, the MWR ought to be able to detect them. Controversial evidence for exploding water geysers that rise far above the Earth and into space is connected to the potential of liquid water nearby. Hydrogen and oxygen clouds in the shape of plumes were first spotted by the Hubble Space Telescope in 2013, and their potential silhouettes were later discovered in 2016. Galileo recorded slight alterations in Jupiter's magnetosphere near Europa, which could be the consequence of charged particles in the plume deflecting the big planet's magnetic field, according to scientists examining archived data from the satellite. Scientists discovered in 2021 that Europa was emitting enough water vapor to quickly fill an Olympic-sized swimming pool, but since water geysers haven't been shown to exist yet, it's still unclear how that water vapor got there. During its flyby, can Juno discover a geyser for the first time? It is unlikely. If the plumes are real, we need to be extremely lucky to fly past them while they are exploding and in a location where we just happen to be watching. However, Juno may still see a geological feature on the surface that is generating water vapor, such as the tiger stripes on Saturn's ice moon and Enceladus that have their own water geysers, even if it doesn't witness a plume in motion. As an alternative, Juno's navigation cameras will look for frozen fragments that are reflecting and scattering light as they slide back down to Europa's surface. Juno will approach Europa from a high inclination, providing the spacecraft its first views of the polar areas of the moon due to its polar orbit around Jupiter, which involves passing over the north and subsequently the south poles. Prior expeditions, in contrast, hugged the moon's equator and concentrated on their equatorial areas. Due to Juno's orbit, this is also the only opportunity for the spacecraft to view Europa up close. Radiation is the main concern. When Juno reaches perigove, which is the term for its closest point to Jupiter, it will be exposed to a significant amount of radiation from charged particles that are trapped in Jupiter's powerful magnetosphere and frequently batter the surface of the planet's moons. Juno is designed like an armored tank with shields to withstand this radiation, but ultimately, our shields will no longer hold, to use Star Trek terminology, and the radiation will begin to damage Juno's electronics. Even though Europa may be Juno's lone chance, it won't be the last spacecraft to travel to Jupiter's ice moons. A recent study found that the underwater snow rises through the water from the global ocean and clings to submerged ravines and inverted ice peaks. The same mechanisms that exist beneath ice shelves on Earth may have an impact on how Europa's ice shell forms. Europa's ice shell could not be as salty as previously thought. Understanding the amount of salt in the ice crust is crucial for engineers preparing for NASA's Europa Clipper mission, which is set to launch to Europa in October 2024. The interplanetary spacecraft Europa Clipper was built by NASA to study Europa through a series of flybys while orbiting the gas giant. The major goal of the Clipper is to determine whether conditions favorable to life exist in the enormous ocean of liquid water underneath Europa's icy surface. Using cues from the ice shell, researchers may discover more about the salinity and viability of Europa's ocean. Europa's ice shell is estimated to be between 10 and 15.5 miles, 15 and 25 kilometers thick, and it likely sits on top of an ocean that is between 40 and 90 miles, 60 and 150 kilometers deep. Scientists are interested in the ocean's salinity and chemistry to establish whether Europa is potentially habitable or even the type of life that may live there. According to earlier research, the ocean closest to Europa's shell has similar temperature, pressure, and salinity to the water below the Antarctic ice shelves. The researchers looked at congelation ice and frazzle ice, the two processes through which water on Earth freezes beneath ice shelves. So what makes the difference? Congelation ice actually forms from below the ice shelf, whereas frazzle ice drifts up through extremely cold seas before resting beneath the ice shelf. When the researchers extrapolated their results to the age and size of Europa's ice shell, they discovered that salt water was even less salty. Both of these types produce ice that is less salty than seawater. There may be more crystalline ice on Europa than previously believed, which would result in a purer ice shell. Fragile ice can only hold a tiny fraction of the salt in seawater. The purity of the ice shell can have an impact on its strength, ice tectonics, and heat conduction capabilities. According to Donald Blankenship, a senior research scientist at the University of Texas Institute for Geophysics, we can utilize Earth to evaluate Europa's habitability, quantify the exchange of pollutants between the ice and ocean, and determine where water is in the ice. When built, Europa Clipper, according to NASA, will be the size of an SUV and feature solar arrays that cover an entire basketball court, making it simpler to power the spacecraft as it travels to Jupiter's icy moon Europa. The Europa Clipper will set foot on the Jovian moon in April 2030. Over the course of nearly 50 scheduled flybys of Europa, the spacecraft will gradually lower from a height of 1,700 miles, 2,735 kilometers over the surface of the moon to only 16 miles, 25 kilometers above it. In order to gather data about the moon Europa's atmosphere, surface, and interior, NASA said the Europa Clipper spacecraft will orbit Jupiter and conduct a number of close flybys of Europa. In addition to the depth and salinity of the ocean, its complicated payload will examine everything from the ice cap's thickness to the features of potential plumes that may be blasting underground water into space. And closest to Jupiter is Io, and this is the one that has scientists on the edge of their seats. Io is as violent as it can get. This moon is actually the most volcanically active body in the solar system. Its surface is covered with hundreds of volcanoes, spewing sulfurous plumes hundreds of miles high. Sandwiched between Europa and Ganymede, Io is used to fighting for its life as it negotiates the gravitation tug-of-war between the two moons and Jupiter itself. These tidal forces are responsible for the massive heat driving Io's intense volcanic activity. Io has an ever-changing landscape as fissures ooze lava onto the moon's surface, filling impact craters and creating new floodplains of liquid rock. Scientists are yet to determine Io's exact composition, but it's suspected to be molten sulfur and its compounds or silicate rock. However, the moon's thin atmosphere is primarily composed of sulfur dioxide. While the volcanoes on Io can reach 3,000 degrees Fahrenheit, Io's surface temperature is about minus 202 degrees Fahrenheit. Because of these extreme temperatures, Io is sometimes called the celestial body of fire and ice. Io is about the same age as Jupiter, which it orbits at about 262,000 miles. The orbit lasts around 1.77 Earth days. The moon has a mean radius of 1,132 miles, a bit larger than the Earth's moon. You may notice from the pictures that Io is not perfectly spherical, but rather oblong. Here is the reason. As Io orbits Jupiter in an elliptical fashion, the strength of Jupiter's gravity on the moon varies depending on how close it is to the planet. This gravitational fluctuation causes a never-ending push and pull on the moon's interior in different directions, and this causes Io's surface to bulge by as much as 330 feet or 100 meters. This movement causes Io's rocks to grind past each other, generating vast quantities of heat, 20 times more heat flows than Earth. If Io were Jupiter's only moon, its orbit would have likely settled down into a circle a long time ago, but poor Io is destined to eternal outward tug from Europa and Ganymede. Io might be small, but it exerts its own influence on Jupiter, and it gets electrifying, literally. You see, Io's orbit cuts across Jupiter's powerful magnetic lines of force, turning Io into an electric generator. Io can develop 400,000 volts across itself this way, and that could create 3 million amperes of electrical current. Ironically, this then makes its way back along Jupiter's magnetic field lines and causes lightning storms in Jupiter's upper atmosphere. But there is more to the relationship between Jupiter and Io. As Jupiter rotates, it is at a personal loss to Io, as the magnetic forces strip away about a ton of its material every second. The material liberated becomes ionized and forms a donut-shaped cloud of radiation called a plasma torus. Some of the ions are pulled into Jupiter's upper atmosphere and create auroras. An example of this activity was spotted by the Hubble Space Telescope, which revealed the influences of Io and another Jovian moon, Ganymede, in Jupiter's auroras. Io has many tricks up its sleeve, and the latest one is what is baffling scientists. Thanks to NASA's spacecraft Juno, they have been listening in on radio emissions coming from Io. So what exactly is going on Io? How did this Jupiter moon, known to be icy, get its dune? Current scientific understanding dictates that dunes, by their nature, are hills or ridges of sand piled up by the wind, and scientists in previous studies of Io, while describing its surface as containing some dune-like features, concluded the ridges could not be dunes since the forces from winds on Io are weak due to the moon's low-density atmosphere. The clue to the answer lies in data that are getting old already. During the Galileo's mission from 1989 to 2003, scientists were able to gather data so numerous that up to this day, nearly 20 years after, scientists are still poring over all the data. It was from this pile that the insights needed to understand what is happening on Io came from, and it had to do with volcanic activities so strong that they are reshaping the surface of the satellite and creating the large-scale features that resemble dunes. So Io's surface contains a mix of black solidified lava flows and sand, flowing effusive lava streams, and snows of sulfur dioxide. The group of researchers actually used mathematical equations to simulate the forces on a single grain of basalt or frost and calculate its path. When lava flows into sulfur dioxide beneath the moon's surface, its venting is dense and fast-moving enough to move grains on Io and possibly enable the formation of large-scale features like dunes. After devising or duplicating the mechanism by which the dunes could form, the researchers checked the photos of Io's surface taken by the Galileo spacecraft for corroboration. The spacing of the crests and the height-to-width ratios they observed were consistent with trends for dunes seen on Earth and other planets. Io's surface is also changing incredibly quickly. On the moon's surface, volcanic cracks spew lava, filling impact craters and forming fresh floodplains of flowing rock. Although the precise makeup of Io is unclear, silicate rock or molten sulfur and its compounds are most likely present. In addition, sulfur dioxide dominates the moon's meager atmosphere. NASA's Voyager missions made the initial discovery of Io's volcanic activity in 1979. Strong tidal forces are what fuel the volcanism on the moon. The intensity of Jupiter's gravity on Io fluctuates depending on how near the moon is to the gas giant as it orbits Jupiter in an elliptical manner. Io's surface can bulge by as much as 330 feet, 100 meters, due to this gravitational fluctuation, which exerts a constant push and pull on the moon's interior in various directions. Due to this movement, the rocks on Io grind against one another, producing a heat flux that is 20 times greater than that of Earth. Io's orbit would have likely settled down into a circle a long time ago if it were Jupiter's lone moon, but the ongoing steady tug from Io's outer neighbors Europa and Ganymede prevent that from happening. Io is trapped in this never-ending game of gravitational tug-of-war which causes the planet to heat up. According to ESA, sulfur and sulfur dioxide make up the majority of Io's surface. Along with hundreds of volcanoes, patches of sulfur dioxide frost have also been seen on the surface. The surface pressure of the atmosphere of Io, which contains sulfur dioxide, is a billionth of that of Earth. But do you know the significant impact Io has on Jupiter? Even though Io is very small, around the size of Earth's moon, the moon nonetheless has a significant influence on its parent planet. Because of the way Io's orbit crosses Jupiter's strong magnetic lines of force, it functions as an electric generator. NASA claims that Io is capable of producing 400,000 volts across itself, which results in 3 million amps of electrical current. Then, as it travels back along the magnetic field lines of Jupiter, it produces lightning storms in the planet's upper atmosphere. Io loses a ton of material every second as Jupiter rotates due to magnetic forces. A plasma torus, which is a donut-shaped cloud of radiation, is created when the substance is ionized. Jupiter's upper atmosphere is filled with some of the ions which cause auroras. Hubble's detection of the effects of Io and another Jovian moon, Ganymede, on Jupiter's auroras in 2018 provides an illustration of this behavior. This year, the James Webb Telescope provided additional proof that auroras on Jupiter are caused by the electric current and volcanoes on the moon Io. Observations from the Texas Echelon Cross Shell Spectrograph and the Gemini North Telescope in Hawaii suggest that Io also has a foldable atmosphere. Every day, Io is in the shadow of Jupiter, causing the sulfur dioxide envelope of gas to freeze up. The freezing sulfur dioxide changes back into gas when Io is exposed to sunlight once more. Researchers discovered corroborating evidence for the existence of this phenomenon only after this study, which was the first to observe Io's atmosphere in the dark. Remember how we said that volcanoes are abundant on this moon and it is subjected to the effects of Jupiter's magnetic forces, and that Io loses 1 ton of gases and particles per second into space, and that they become ionized when they split into ions and electrons and rain down on Jupiter. Well, when the electrons are caught in the magnetic field and accelerated towards Jupiter's pole, they generate something scientists call decimeter radio waves, decimetric radio emissions, or DAM. When Juno is properly positioned, its instrument can pick up these radio waves. Using this data, researchers have pinpointed where in Jupiter's massive magnetic field the radio emissions come from. The data has also shed light on the behavior of the enormous magnetic fields gas giants create. According to the research team, the radio waves come from a space that can be described as a hollow cone where the conditions are just right, the right magnetic field strength and the right density of electrons. The signal rotates like a lighthouse, and Juno picks it up only when the light is shining on the spacecraft. The radio data also show that the electrons that create these radio waves emit a massive amount of energy, which turned out to be 23 times greater than researchers thought. They discovered that these electrons could come from other sources too, such as from the planet's magnetic field or from solar winds. Not very far from Jupiter, Uranus is also behaving mysteriously. While the planet orbits even farther from the Sun than Jupiter, a strange heat wave is causing Uranus's rings to warm up, despite being so far from the Sun. This was discovered in new heat images of Uranus obtained by 2 ground-based telescopes in Chile. The telescopes revealed the temperatures of the rings for the first time, and it was minus 320 degrees Fahrenheit. This is the temperature at which liquid nitrogen boils. That might be extremely cold by Earth standards, but out there in space where the temperature can approach absolute zero, at which atoms cease movement altogether, minus 320 degrees is quite warm. Uranus is so far from the Sun that it only receives a fraction of the heat from the Sun that the Earth receives. The ice giant orbits the Sun at an average distance of 19 AUs. So just what is causing this relative warmth? Scientists still don't know, but the strange temperature proves that the brightest and densest ring at Uranus, or the Epsilon ring, is very different from other ring systems in our solar system. Every giant planet in our solar system, that is Jupiter, Saturn, Uranus, and Neptune, has its own set of rings, but out of all of them, Saturn's rings are the most spectacular and best understood. That's because they're easily visible even with just a small telescope, and because NASA's Cassini mission studied them up close. But Saturn's rings are quite different from those of Uranus. There is another group of Jovian moons known as the Amalthea group. They are smaller in size with diameters less than 200 kilometers and orbit the planet at orbits less than 200,000 kilometers in radius. They are Metis, Adrestia, Amalthea, and Thebe. These moons, along with others, help Jupiter to maintain its rings. There are other irregular satellites attached to Jupiter. They are noticeably small and have larger and eccentric orbits. Scientists theorize these objects were formed as a result of collisions between larger objects and were simply trapped by Jupiter's gravity. In fact, the moons of Jupiter did send scientists on a wild goose chase recently. What happened? In 2017, astronomers searched for the theoretical Planet X. something outside our solar system is tugging at objects within. As this could be the missing planet, scientists turned a powerful telescope in that direction. They did not find proof of a ninth planet, but the same patch of sky contained Jupiter. But where did the idea of Planet X come from? That takes us back to the early 19th century, a time scientists knew about all the major planets in the solar system except Neptune. Thanks to Newton's law of motion, they could predict the planet's movement, but they discovered that Uranus wasn't moving as predicted, and they began to wonder if it was an unseen planet pulling at Uranus and sending it off course. When Neptune was eventually discovered, they realized it was not enough to explain Uranus's weird movement. This led some scientists to suggest the existence of a ninth planet, which was named Planet X by Percival Lowell. The American astronomer built an observatory to find Planet X, but didn't find it before his death. Even the discovery of Pluto, which is no longer considered a planet, could not explain Uranus's movement. Some astronomers are still searching for Planet X. So back to 2017, when the astronomers were scanning a section of the sky containing Jupiter while searching for Planet X. Somebody had a moment of quick thinking and viewed the gas giant itself and noticed more moons. All told, the team found 10 new moons orbiting Jupiter, bringing the total number of Jupiter's known moons to 79. One of the new moons is quite the weird one. Jupiter's moons move in packs, and 2 of the new satellites spin with a group that rotates in the same direction as the gas giant. The rest showed up in a cluster that spun against the planet's rotation. This is what astronomers refer to as retrograde. The weird new moon was inside this group but spinning with Jupiter. Called Valetudo, it could have a short lifetime. Being an anti-retrograde moon within a retrograde cluster, a future collision is inevitable. Speaking of gravity, as the heaviest planet in the solar system, Jupiter has the most intense gravity. You will experience 2.5 times more gravity on Jupiter than on Earth. This gravity is so strong that it tore apart an asteroid known as Shoemaker-Levy 9 and sucked the broken pieces into itself. The asteroid was actually captured between 20 and 30 years before the impact and has been orbiting the planet since. But in 1992, the asteroid entered Jupiter's Roche limit and was broken apart by the planet's tidal forces. The asteroid looked like a string of pearls until its fragments impacted the surface in July 1994. The fragments were as large as 2 kilometers each and hit the surface at 60 kilometers per second. The impacts were a boon for scientists as they allowed astronomers to make several new discoveries about Jupiter. They were able to spot some chemical compounds that were not seen before the impact in the Jovian atmosphere. Among the new chemicals were diatomic sulfur and carbon disulfide. It was the second time the former was detected in any celestial object. It was also the first time researchers discovered ammonia and hydrogen sulfide on the planet. What is interesting, and at the same time scary, is that Jupiter's powerful gravity may cause serious problems for Mercury and the rest of the solar system. How? While the solar system may seem to be stable, problems could be brewing, and Jupiter is at the center of it. The problem is that Jupiter has a disproportionately huge gravitational influence over its siblings, and the smaller planets bear the worst of the effect, and they may actually be doomed. The huge gravitational pull of Jupiter seems to be bullying Mercury into an increasingly eccentric death orbit, which might end up flinging the lighter planet into the path of Venus. Considering we inhabit a neighboring planet to these two, things might not be so rosy for the Earth either. Jupiter orbits the Sun at a distance of about 748 million kilometers, which is 5 times further away from the Sun than the Earth. But that doesn't mean we are high and dry. Although this distance may be huge, this 318 Earth-mass planet's gravitational pull is very important to the inner solar system planets, including tiny Mercury. Mercury has an elliptical orbit around the Sun, bringing it as close as 0.31 astronomical units to the Sun and taking it 0.47 astronomical units away from it. 1 astronomical unit is the distance between the Sun and the Earth. However, Mercury is only 0.055 times the Earth's mass, or just 5 times heavier than the Moon. After running long-term simulations on the orbits of solar system bodies, scientists in France and California have realized that Jupiter's gravity may disturb Mercury's eccentric orbit even more. Their simulation predicts that Mercury's orbit may extend into the path of Venus, or it might just fall into the Sun. They claim there are 4 possibilities awaiting Mercury if Jupiter continues to exert a gravitational pull on it. Mercury will crash into the Sun. Mercury could be ejected from the solar system altogether. Mercury could crash into Venus, or Mercury could crash into Earth. The last option is obviously the worst-case scenario for us on Earth, but all will be bad news for Mercury. The small planet's fate appears to be sealed. But what happens if Mercury smashes into the Earth? It won't actually be the first celestial object to do that. However, the asteroid that most likely wiped out the dinosaurs when it impacted the Earth will seem like a drop in the ocean compared with a planet 4,880 kilometers in diameter slamming into us. In fact, there will be very little left after this wrecking ball impact. Hopefully by that time, Elon Musk would have gotten his Mars colonization effort underway, as that is the only scenario that humans escape and continue to exist. Sadly, even Musk's efforts may not save us, as the Sun is more likely to first turn into a red giant and swallow Mercury, Venus, the Earth, and Mars altogether. Many people have younger and smaller siblings that they will protect jealously. However, that is not the case with Jupiter. Instead of being a protective big brother to the Earth, the jumbo planet actually puts us in harm's way. Using computer simulation, scientists have found the largest planet in our solar system's gravity hurls deadly asteroids towards us instead of keeping them away as previously assumed. Scary, right? A paper worked on by NASA's Jet Propulsion Laboratory suggested evidence shows Jupiter was not a protector planet, using its own gravity to suck asteroids away from Earth's path. Jupiter's gravity may actually nudge some asteroids toward the Sun, where they stand a chance of colliding with our planet home. For many years, our understanding of the relationship between the Earth and Jupiter has been shaped by the Jupiter shield theory, which says the bigger planet acts like a giant space shield due to its huge mass, which causes it to suck in or deflect dangerous debris. But now, thanks to the work of Kevin Grazier, the shield theory is slowly falling out of favor. He published several papers explaining why he thinks Jupiter is a sniper rather than a shield. Actually, the relationship is complicated because Jupiter sometimes protects the Earth by deflecting comets away from the Earth, but new evidence proves that it's just as likely to take objects that come nowhere from the Earth and flings them in our direction. Of course, comet and asteroid strikes on the Earth are no jokes. You can ask the poor dinosaurs that went extinct. However, space is full of these dangerous objects, and the Earth needs protection, so it's important to establish whether Jupiter is a friend or foe. Interestingly, it took strikes by comets and asteroids on the Earth when it was young before all the ingredients needed for life were assembled, but they could as well wipe out the life they have created in a few seconds. Overall, Jupiter is our friend because it slings most of the comets coming from outside the solar system back out. There are even signs that it has taken hits on our behalf. While Jupiter may appear to be a big bully today, you may want to cut it some slack due to its childhood. A new scientific discovery showed evidence of a traumatic childhood. In 2018, a study found that the largest planet suffered a delayed growth spurt. Most scientists accept the solar system's beginnings start with the Sun orbited by a dust-filled gas cloud. Then pieces started to glom together into lumps, which then formed larger bodies that grew into the planets of today. Such a serene upbringing was not something Jupiter had as a kid. It was the odd kid out. At first, small clumps fattened the planet up for 1 million years. After ballooning to a stage where it could beat Earth's mass 20 times over, Jupiter's growth ceased. Suddenly, massive worlds smashed into the planet. However, instead of adding mass to Jupiter, they injected energy. This created zones with so much heat and energy that gas molecules struggled to merge with Jupiter. The bombardment continued for another 2 million years and ground the planet's growth down to a snail's pace. Even so, Jupiter grew to 50 times Earth's mass. After that stage, the planet gorged on gas and quickly swelled to its current mass, which equals hundreds of times more than the Earth's. The next discovery on Jupiter involved an event that scientists assumed was a comet strike on the planet, but turned out not to be so. What then exactly happened? From the Earth, astronomers noticed a flash that lasted only 2 seconds and was gone. They immediately suspected that the giant planet had been hit by something, although they didn't know how big the object was or how deep the atmosphere was penetrated. The next step was to begin searching for a black eye pattern left by former impactors, but they eventually turned to the Hubble telescope for help. But not even the telescope could sight anything, as there was no sign of debris. The implication after 3 days was that the object that struck the planet did not descend beneath the clouds and explode as a fireball. If that had been the case, the dark sooty debris would definitely have been ejected to rain down onto the clouds, so it was assumed the flash came from a giant meteor burning high above Jupiter's cloud tops. Even though Jupiter is massive, it is by no means a slow planet. In fact, Jupiter is the fastest spinning planet in the solar system. This is like the heaviest kid in the class winning the sprint races. Jupiter has a rotational velocity of 12.6 kilometers per second, or 45,300 kilometers per hour, which means it takes only 10 hours to complete a full rotation on its own axis. You know what that means? Jupiter will complete nearly 2.5 days before the Earth does. Jupiter spins so fast that it's flattened out at the poles and bulges at the equator. As a result, Jupiter's polar radius is about 67,000 kilometers, 10.5 times more than the Earth, while its diameter at the equator is 71,500 kilometers, 11 times more than the Earth's. This fast rotation contributes to Jupiter's powerful magnetic fields. In fact, scientists claim that should you lose your way on the planet, you can find your way using a compass, just as you can do on Earth. Jupiter has the strongest magnetic field of any planet in the solar system, and this is likely due to eddy currents, or the swirling movement of conducting materials inside the liquid metallic hydrogen core. The magnetic field traps particles made up of sulfur dioxide from one of Jupiter's moon's volcanic eruptions. The process produces sulfur and oxygen ions that, combined with hydrogen atoms inside the planet's atmosphere, form a plasma sheet in its equatorial plane. The same high-speed rotation has another effect on Jupiter, this time a very dangerous one. The interaction of the magnetosphere with the solar wind generates a bow shock, or a dangerous belt of radiation that can damage spacecraft. Jupiter's 4 largest moons all orbit within the magnetosphere, which protects them from the solar wind, but also makes the likelihood of establishing outposts on their surface problematic. The magnetosphere of Jupiter is also responsible for intense episodes of radio emission from the planet's polar regions. Now we will talk about Jupiter's moon Io again in the next discovery by scientists. How did this Jupiter moon, known to be icy, get its dune? Current scientific understanding dictates that dunes by their nature are hills or ridges of sand piled up by the wind, and scientists in previous studies of Io, while describing its surface as containing some dune-like features, concluded the ridges could not be dune since the forces from winds on Io are weak due to the moon's low-density atmosphere. The clue to the answer lies in data that are getting old already. During the Galileo's mission from 1989 to 2003, scientists were able to gather data so numerous that up to this day, nearly 20 years after, scientists are still poring over all the data. It was from this pile that the insights needed to understand what is happening on Io came from, and it had to do with volcanic activities so strong that they are reshaping the surface of the satellite and creating the large-scale features that resemble dunes. So Io's surface contains a mix of black solidified lava flows and sand, flowing effusive lava streams, and snows of sulfur dioxide. The group of researchers actually used mathematical equations to simulate the forces on a single grain of basalt or frost and calculate its path. When lava flows into sulfur dioxide beneath the moon's surface, its venting is dense and fast-moving enough to move grains on Io and possibly enable the formation of large-scale features like dunes. After devising or duplicating the mechanism by which the dunes could form, the researchers checked the photos of Io's surface taken by the Galileo spacecraft for corroboration. The spacing of the crests and the height-to-width ratios they observed were consistent with trends for dunes seen on Earth and other planets. One of the wonders of Jupiter is the Great Red Spot. In fact, it is one of the defining features of the planet. This feature is an anticyclonic storm found on the south of its equator. While it appears small when viewed from the Earth, this storm actually measures between 24,000 kilometers in diameter and 12,000 to 14,000 kilometers in height. This is a storm you want to avoid at all costs. At this size, it is large enough to swallow 2 or 3 planets the size of Earth's diameter. One thing about the Great Red Spot is its longevity. It has been around for at least 350 years. This is because it was spotted for the first time in the 17th century. The credit for the discovery of the Great Red Spot goes to Giovanni Cassini, who saw it in 1665, although he wasn't sure of what it was. But by the 20th century, astronomers had begun to theorize that it was a storm, and that it was formed as a result of Jupiter's turbulent, fast-moving atmosphere. These hypotheses were confirmed when the Voyager 1 spacecraft had a close observation of the planet during a flyby in 1979. Since then, scientists say this storm has been shrinking. It has come down to its present size from about 40,000 kilometers based on Cassini's records, which would mean it's now half of its former size. Will the Great Red Spot ever disappear? Nobody knows for sure if and when it will do so. However, they are sure that another storm will form somewhere else on this vast planet. Now, if you have heard of the Great Red Spot on Jupiter, are you aware that there is a Great Blue Spot on the planet as well? What is the Great Blue Spot all about? It is magnetic. A team of NASA researchers, including Jack Conanay, came up with the most detailed map of the planet's magnetic field, and it revealed something spectacular. The map is compiled from data obtained from 32 orbits during Juno's prime mission. The group of researchers claimed their new map provides new insights into Jupiter's mysterious Great Blue Spot, a magnetic anomaly at the planet's equator. Juno data indicate that a change in the gas giant's magnetic field has occurred during the spacecraft's 5 years in orbit. What is happening is that the Great Blue Spot is drifting eastward at a speed of about 2 inches or 4 centimeters per second relative to the rest of Jupiter's interior. At that rate, the Great Blue Spot will go around the planet completely in about 350 years. In contrast, the more popular Great Red Spot, the long-lived atmospheric anticyclone just south of Jupiter's equator that refused to die, is drifting westward at a relatively rapid clip, going round the planet in only about 4.5 years. Apart from this, the new map shows that Jupiter's zonal winds are pulling the Great Blue Spot apart. Zonal winds are jet streams that run east to west and west to east, which gives Jupiter its distinctive banded appearance. This means that the zonal winds measured on the surface of the planet reach deep into the planet's interior. The new magnetic field map also enables Juno scientists to make comparisons with Earth's magnetic field. The data suggests to the team that dynamo action, that is, the mechanism by which a celestial body generates a magnetic field in Jupiter's interior, occurs in metallic hydrogen beneath a layer expressing helium rain. In all of this, you may be asking if there is a possibility of life on Jupiter. Data from NASA's Juno probe indicates that about 0.25% of the molecules in the atmosphere over Jupiter's equator is composed of water. Let us save you the mathematical calculation and expression of that 0.25%. That 0.25% is based on a prevalence of water's components, hydrogen and oxygen, 3 times more than at the Sun. Amazing! Why this data is amazing and shocking was that NASA's Galileo data about Jupiter was different. After this latest discovery, scientists checked Galileo's result and compared, and they discovered something. What did they discover? They discovered that the result of Galileo's was drier than that of Juno. Galileo's results sent back data showing 10 times less water than scientists predicted, and more weirdly, the amount of water appeared to increase the deeper the spacecraft went into Jupiter's atmosphere. It happened that at the same time Galileo was plunging into Jupiter, there was a ground-based infrared telescope that was able to measure water concentrations at Jupiter. This telescope showed that Galileo may have accidentally hit a dry spot during its probe. This could mean only one thing: water is not well mixed deep in Jupiter's atmosphere. This is also proven by Juno during its first 8 flybys. It revealed that there is a lack of atmospheric mixing on the planet and its surrounding systems. Juno principal investigator at the Southwest Research Institute, Scott Bolton, said in a statement, "Just when we think we have things figured out, Jupiter reminds us how much we still have to learn." He added, "Juno's surprise discovery that the atmosphere was not well mixed, even well below the cloud tops, is a puzzle that we are still trying to figure out. No one would have guessed that water might be so variable across the planet." Working with the results of Galileo's probe and that of Juno, scientists will be able to get more details about Jupiter, the Jovian system, and the solar system. Jupiter is known to probably be the first planet to form,
This indicates that Jupiter could have sucked up most of the gas and dust that the Sun's formation left behind. Then the question, how much water did Jupiter suck? Did its moons take part in the evaporation of water? Answers to these questions would lead scientists to identify the most plausible theories to explain its formation.
And now we come back to the massive size of Jupiter because scientists have discovered the effect it has on the whole solar system. Thanks to its massive gravity, Jupiter has been fingered for pushing planets Neptune and Uranus away from the Sun. This is due to a theory known as the NICE model, which claims that Jupiter and other gas giants caused a phenomenon known as the Late Heavy Bombardment, a time when the Earth and other planets nearby were bombarded with debris. However, that was in the past, as Jupiter now plays a mostly protective role to our planet. Jupiter helps to keep asteroids and comets from bombarding Earth, protecting the inner planets by acting as the vacuum cleaner of the solar system. The enormous gravity it generates can suck in and absorb smaller objects, like the 1994 collision of Jupiter and comet Shoemaker-Levy 9. Jupiter can also propel them out of the solar system entirely, but that same gravity can still accelerate some of those objects toward the inner planets too, so it's a mixed blessing. In all of this, you may be asking if there is a possibility of life on Jupiter. Well, according to scientists, if life were to be on Jupiter, it would have to exist at a height literally in the clouds, where the temperature is about 70 degrees Fahrenheit or 21 degrees Celsius. But studies suggest Jupiter has enough water to sustain life, so perhaps one day we... Apart from the Great Red Spot, Jupiter is known for its violent weather patterns. If you have any business on the planet, you must get ready to cope with wind speeds of up to 100 meters per second or 360 kilometers per hour. That would even be the norm, as winds can get as fast as 620 kilometers per hour. Storms form within hours and can become thousands of kilometers in diameter overnight. Over time, scientists have discovered 3 forms of radio signals emitting from Jupiter. These are decametric radio bursts, decimetric radio emissions, and thermal radiation. The first type, decametric bursts, vary with the rotation of Jupiter and are influenced by the interaction of Io with Jupiter's magnetic field. The second type is decimetric radio emissions, which have been traced down to a torus-shaped belt around Jupiter's equator. They are caused by cyclotronic radiation from electrons that are accelerated in Jupiter's magnetic field. The last one, thermal radiation, is produced by heat in Jupiter's atmosphere. Visualizations of Jupiter using radio telescopes have allowed astronomers to learn much about its atmosphere, thermal properties, and behavior. In mid-2021, NASA released a 50-second audio clip at the American Geophysical Union AGU meeting. Hold up, what? 50-second audio is definitely no joke. Could it be that some aliens are planning to invade Earth? The audio clip was gotten from Juno's Ganymede flyby. It was generated from data captured on June 7, 2021, during the spacecraft's closest pass yet to Ganymede. The sound was similar to that of a robot or a dial-up modem. This discovery joined the list of fascinating discoveries of Jupiter alongside the presence of water molecules. The audio was captured by Juno's Waves instrument, which was designed to measure radio and plasma waves detected in Jupiter's magnetosphere, the bubble of charged particles that envelop the planet. Commenting on the audio, Scott Bolton said, "The soundtrack is just wild enough to make you feel as if you are riding along as Juno sails past Ganymede for the first time in more than 2 decades." Scientists are still studying the wave data collected during the Juno flyby and attempting to decode what frequency changes are present within the recording mean. Now, here is a piece of scientific discovery that might shatter everything you thought you knew about Jupiter and even the solar system itself. While you might have seen a million pictures of the solar system showing all the planets orbiting the Sun, and yes, we have mentioned Jupiter orbiting the Sun in this video, technically, Jupiter doesn't orbit the Sun. It actually orbits a spot in empty space between it and the Sun called the barycenter. This is because the Sun doesn't just exert gravity on Jupiter. Jupiter is so big that its own pull affects how the Sun moves too. While the Sun is about 1,000 times more massive than Jupiter, the two bodies affect one another proportionally according to distance and mass. This means the amount of Jupiter's pull on the Sun is 1,000th the amount of the Sun's pull on Jupiter. The Sol-Jupiter barycenter sits 1.07 times the radius of the Sun from the Sun's center, or 7% the radius of the Sun from the surface. The Sun also orbits this spot. If you were to look at the planetary plane from above, you'd notice a slight wobble as the Sun moves around the Milky Way. The next discovery involves an incredible similarity between the Earth and Jupiter. Look at the images below. Do you see the eerie similarities between the two? One image was taken on the Earth, while the other was taken on Jupiter, yet they look frighteningly alike. So what is going on here? On the left is a phytoplankton bloom in Earth's Norwegian Sea, while on the right, you are looking at turbulent clouds in Jupiter's atmosphere. Here is NASA's explanation. The simplified model of Jupiter's pole shows that geometric patterns of vortices, like those observed on Jupiter, spontaneously emerge and survive forever. This means that the basic geometrical configuration of the planet allows these intriguing structures to form. Although Jupiter's energy system is on a scale much larger than Earth's, understanding the dynamics of the Jovian atmosphere could help us understand the physical mechanisms at play on our own planet. Oceanographers have used Juno's images to study the turbulent atmosphere at Jupiter's poles, helping us understand the forces that drive the storms there. Did you know there is lightning on Jupiter, even though there is nobody there to see it? Stormy weather rules Jupiter's atmosphere, and this has made astronomers long assume that there would be lightning, and this was confirmed in 1979. However, what they didn't envisage was how strange the lightning would be. Lightning releases radio waves, and for decades, every probe that visited the planet recorded something unusual. Lightning on Jupiter only signaled in the low-frequency range, and no known theory could explain why, as Earth's lightning emitted radio waves from low to very high frequencies. However, in 2018, the Juno spacecraft finally solved the mystery. As it turns out, the problem was not with Jupiter, but with the limits of human technology. The case was simply that previous spacecraft could not match the sensitivity of Juno's equipment or get as close to Jupiter as Juno got. Not only did it record megahertz strikes, but some even zinged around in the gigahertz range. Intriguingly, the probe also confirmed that Jupiter's lightning was nothing like the ones on Earth. Lightning on Earth avoids the poles and prefers to zap the equator. The gas giant's equatorial zone has no lightning. Instead, it lights up Jupiter's poles with a peak frequency of 4 bolts per second. Auroras are some of the most strikingly beautiful natural phenomena on Earth. Jupiter boasts the same amazing phenomenon, and this is courtesy of 4 of its moons. When in close orbit, the moons influence something that scientists call plasma. When perturbed, this layer of charged particles triggers the auroras at Jupiter's poles. But to see this spectacular light show, you need to be equipped with ultraviolet and infrared equipment. In 2017, NASA's Juno spacecraft captured the closest view of Jupiter and took images of what you can call the moon's auroral footprints. The results showed something unexpected, but that was to be expected as Jupiter is always throwing up surprises. Previously, the patterns were considered simple and random, but the researchers discovered that the swirls were complex and unique to each moon. In particular, Io's contribution stood out. Scientists predicted a plain big spot, but what they got was a footprint with a tail that spawned its own vortices. Ganymede, the only moon with its own magnetosphere, also triggered something unique: twin footprints. The double auroras are probably the offspring of the moon's magnetic field inside Jupiter's, but scientists cannot begin to explain Io's strangely patterned auroras. Another discovery on Jupiter that has puzzled scientists is one that cannot be observed from the Earth. This discovery is linked to the planet's poles, which you need a spacecraft to see. What baffled scientists was that the cyclones encircling Jupiter's poles mysteriously arranged themselves in clusters with pentagonal and other geometric shapes. It was the visible and infrared images taken by the Juno spacecraft in orbit around Jupiter that revealed giant cyclones arranged in geometric patterns at the planet's poles. At Jupiter's North Pole, one cyclone, about 2,485 miles or 4,000 kilometers wide, has 8 cyclones, each of a similar diameter, surrounding it. Coming to the South Pole, one cyclone that is about 3,975 miles or 6,400 kilometers wide is encircled by 5 cyclones ranging in size from 3,480 miles to 4,350 miles. Each of these cyclones lasted for at least 7 months. In each cluster, the cyclones were close enough to each other to essentially be in contact. This find reminded scientists of similar discoveries on another gas giant, Saturn. This second largest planet in the solar system has a single cyclone at each pole, and this made scientists suspect Jupiter would have something similar. But of course, while Jupiter also has cyclones, they are different from what Saturn has. In fact, the scientists involved said it was a cautionary tale on making assumptions about a planet based on findings on another planet. But how they managed to last 7 months and managed not to merge remains a mystery. Even their geometric formation has not been explained. Looking at the image of Jupiter, some of the things that stand out include its stripes. While it may look like just another mark on the planet, scientists have found some amazing things about these stripes. For example, these stripes run more than 1,000 meters deep. Apart from the massive depth, they hold so much gas that their mass is about 3 times more than the mass of the entire Earth. Of course, these bands have been known for centuries since Galileo pointed his telescope at the planet, but it's recently that scientists are getting to know just how deep these stripes are, and this knowledge is all thanks to Juno. The spacecraft has provided a 3D picture of these stripes, allowing researchers to see the extent of their depth. Juno orbits Jupiter once every 53 days. As the planet's gravitational field tugs on Juno, it causes the radio signals that the probe sends back to Earth to shift a bit. The greater the mass under Juno, the stronger the gravitational pull the spacecraft and its radio waves experience. Now, because Juno's flybys are in different orbits each time, it can map the gravitational field of different parts of the planet. As Jupiter's belts of winds can flow at very high speed, they affect how mass is spread across the planet. What this means is that mapping Jupiter's gravitational field can shed light on how deep these winds really extend below the surface. The researchers discovered that these stripes extend 1,800 miles deep, or about 1/20th the distance to the center of the planet, far deeper than previously thought. These flows on Jupiter contain about 1% the mass of Jupiter. In comparison, Earth's atmosphere is less than 1/millionth the mass of Earth. Apart from that, the data revealed that beneath the level of these winds, the planet's interior moves as a single body. In other words, it behaves as if it were a rigid solid despite its fluid nature. Prior work suggested this is because of the high pressures found within Jupiter. The hydrogen that makes up much of the planet separates into protons and electrons that generate strong magnetic drag forces that suppress winds flowing in opposite directions. Meanwhile, scientists have discovered that outside the solar system, planets can get even larger than Jupiter. The category of planets known as super-Jupiters has been expanding thanks to the discovery of exoplanets using the Kepler space probes and some ground-based telescopes. Hundreds of such massive super-exoplanets have been discovered so far. An example is the Methuselah or PSR B162026b, the very first super-Jupiter planet to be discovered. The planet is so named because at 12.7 billion years, it is the third oldest known planet in the universe. Also on the list are HD 80606b or Niobe, with the most eccentric orbit for any planet, and 2M1207b or Lerner, orbiting the brown dwarf star Fomalhaut b. And with the new James Webb Space Telescope in action, scientists are expecting to discover even more exoplanets, and these may include more super-Jupiter planets. It's important to know that Jupiter began its life by accreting rocky material just like every other planet in the solar system, even though today it may primarily be a ball of swirling gas. The planet's rocky core grew increasingly dense as more and more rocks were drawn in by the planet's gravity. This dense core began drawing massive amounts of gas from a great distance, primarily hydrogen and helium, left over from the Sun's creation to form the planet's massive atmosphere. But just how Jupiter managed to gather its first rocky material is the subject of two opposing theories. One hypothesis holds that Jupiter gathered billions of smaller space rocks known as pebbles, although these rocks are likely closer in size to boulders rather than actual pebbles. According to the results of a recent study, the alternative theory proposes that Jupiter's core was created by the absorption of numerous planetesimals, huge space rocks with a diameter of several miles that, if left undisturbed, might have served as seeds for the formation of smaller rocky planets like Earth or Mars. Which of these theories is true, nevertheless, has not been able to be determined with certainty up until this point. Because we cannot directly observe how Jupiter was formed, we have to put the pieces together with the information we have today, Miguel said, and this is not an easy task. Researchers needed to create a model of Jupiter's interior in order to attempt and resolve the controversy. Miguel said that seismographs were used on Earth to use earthquakes to analyze the planet's interior. However, she continued, Jupiter lacks a surface on which to mount such apparatuses, and its core is not anticipated to experience significant tectonic action. Instead, they combined data primarily gathered by Juno with a small amount from its predecessor Galileo to create computer simulations of Jupiter's interior. At various locations in the planet's orbit, the probes measured the gravitational field of the planet. According to the data, Jupiter is accreting rocky material with a high concentration of heavy elements. Since these heavy elements combine to form dense solids, they have a stronger gravitational pull than the gaseous atmosphere. The researchers use this information to map out the planet's subtle gravity variations, which help them determine where the planet's rocky material is located. Models developed by the researchers showed that Jupiter has substantially more heavy elements than predicted, between 11 and 30 Earth masses worth, 3 to 9% of Jupiter's mass. The pebble accretion explanation is unable to account for such a high concentration of heavy elements, which is why the new models suggest a planetesimal gobbling origin for Jupiter. The ultimate beginning of the gas accretion process, if the planet was large enough, would have instantly ended the rocky accretion stage if Jupiter had originally formed from pebbles. This is due to the pressure barrier that would have been generated by the expanding layer of gas, Miguel stated, preventing new pebbles from being drawn within the planet. It is likely that Jupiter had a far lower heavy metal abundance or metallicity than what the researchers predicted as a result of this slowed rocky accretion phase. The gravitational attraction on the rocks would have been greater than the pressure from the gas. Therefore, planetesimals may still have clung to Jupiter's core after the gas accretion phase had started. The researchers claimed that the planetesimal theory's simultaneous accretion of rocky material and gas is the only explanation for Jupiter's high concentrations of heavy elements. Another intriguing result from the study was that, contrary to earlier expectations, Jupiter's interior does not mix well with its upper atmosphere. The newly created internal model of Jupiter reveals that the majority of the heavy elements it has taken in have remained close to its core and lower atmosphere. In order for hotter gases near the planet's core to rise to the outer atmosphere before cooling and dropping back down, researchers had thought that convection mixed up Jupiter's atmosphere. If this were the case, the heavier elements would be more equally dispersed throughout the atmosphere. Miguel added that additional investigation is required to pinpoint exactly what is occurring inside the atmosphere of the gas giant Jupiter, but it's likely that some areas of the gas giant may have a slight convection effect. The discoveries of the researchers might alter the origin narratives for other planets in the solar system. Jupiter was the planet that had the most impact on the creation of the solar system, according to Miguel. The size and orbits of its cosmic neighbors were shaped by its gravitational pull, so learning how it formed has crucial ramifications for future planets, she noted. The discoveries also point to a possible planetesimal genesis for Saturn, Uranus, and Neptune, the three gas giants in the solar system. It's possible that additional gaseous planets in other star systems formed by consuming planetesimals rather than pebbles, which means they might have more metallicity than their outward appearance would indicate. Therefore, the researchers added, it's crucial that we don't categorize these new worlds by their clouded surfaces when we discover them with NASA's James Webb telescope. And in other news, in what appears to be a new era of space exploration, NASA recently announced that it had chosen 13 potential landing sites on the Moon as it gets ready to send astronauts back there as part of the Artemis mission. With this mission, the first crew to return to the lunar surface since the Apollo missions of 1969 to 1972, the first woman and person of color will set foot on the Moon. It's really a new era of space exploration, don't you agree? Let us know what you think of these discoveries in the comments section below.